Good afternoon, everyone. I am Chandar sir from GKD here. First of all, thank you very much for joining the webinar during this pandemic time. We will start this webinar shortly. Meanwhile, let me take an opportunity to introduce our GKD here. GKD Institute for Technological Resources is a unit of GKD Charity Trust Coimbatore. It was established by late Cavalier Dr. D. Jayavardhana Velu, former chairman, Lakshmi Machine Works Limited. For the first time in our country, GKD is tied up with Tata Institute of Social Sciences and Alagappa University for commenced university model degree level technological skill development program in the domain of manufacturing, automation, and foundry technology. Moreover, GKD has FANUC India certified CNC and Robot Training Center.
Thank you for joining us for today's webinar. Latest trends in new product development cycle and Fixture concept design to perfectness in CNC machining. The goal of doing this webinar is every year customers were changed. However, knowing that what your target customer favorite and required a few months ago is not enough to establish the same expectation for new development today. Why? Because there are ever changing in the face of unexpected situation, and the success of your product launch is reliant on your abilities to stay up. If you could all of us agree on one thing, agile insights would be important in making rapid choices to drive organization forward. Some people are saying 2 weeks is agile, and that is not a correct situation now. 12 to 24 hours is agile. Old practices are not able to answer today's business challenges. The shock of the year wanted this all of us to ask business questions and create a space for agile solutions. The research outcomes show that though COVID-19 customer shopping habits and could feed that straight into our forecasting models 2 to 3 times a week, and the ability to feed that insight into our business in real time was critical to business planning. Now the pressure is on for all the organizations in the worldwide, fueling the needs of efficiencies and every stage of process to drive the quality insights of at pace. Good companies manage engineering. I repeat once again, good companies manage engineering, but good companies manage product. I believe that by participating in this webinar, we are in the right place and right time. Together, let us accelerate the exchange of ideas and scaling up good business. Now, without further delay, we'll turn the time over to the speaker. Our today's speaker is Mr. Ajitha Prabhu, Director of Createch Services, domain expert in smart manufacturing with NPD and the design of jigs and fixtures and CAD/CAM. Mr. Ajitha has got 20 years in experience in manufacturing. I invite Mr. Ajitha to deliver this webinar. Mr. Ajitha, the floor is yours.
Yeah, thanks a lot. Once again, happy warm evening to everyone. Thanks, Mr. Bala and Mr. Chandrasekhar. Now I'm just making a presentation. Is my voice is audible?
Yes, sir. It's very clear.
Yes, sir. Yes, sir.
Yeah, fantastic.
Very clear, sir.
Yeah. As Mr. Bala introduced, it's all we are into all agile manufacturing, and as I said, the good companies manages good engineering and good product. It's absolutely true. Maybe another 60 minutes to 90 minutes, we are going to see what are the latest trend. And let us go into the basics, basically. Say what always I can say, always the basics are pillar for any subject. For today, we're going to cover about what are the latest technologies are happening in the industry in new product development cycle. And same way, what are the fixture design, concept design to the perfectness. Let us just think about, always we can say, we're all in mechanical industry. We can proud to say that we are equivalent to God. It's not a pride. Mechanical engineers, we create a product. None other anybody can create that. We can feel it, we can touch it, we can give a life to any part. And let us just take how the industry evolution taken place into the mechanical industry. I don't know how many of you know this particular man who is using bullock cart is doing. It's called pulao. Today, nobody you can see. It's all in 1940s. From 1940s, the technology transformation started, and you can see the people moved with the tractors, and that's where the agricultural age started. Then in 1970s, we should say thanks to Henry Ford. Henry Ford found motor car in the world, and afterwards everybody started producing a lot of cars. Two-wheelers subsequently followed, and 1970s onwards the industrial revolution started coming, and 2000 near the IT started coming. It's basically you take anything, maybe into the starting with the CAM or maybe the banking, and any area if you take, it's information age started. Then we are into currently today in 2020 we are into the conceptual age. As Mr. Bala rightly pointed out, we are into the pandemic age, and earlier imagine to identify or to invent or to introduce one vaccine, it takes decade, 10 years, but today we are able to produce all within a year, and that's not applicable only to the pandemic situation in medical field. And if you take any field, you are into the conceptual age. If you have an idea, the same can be manufactured. Let me just put forward, as I said, the mechanical engineers are really the great. If you have idea, the same has to be produced. It's called product. How you can produce a part? As I said, that's called new product development. How the part can be produced? You have idea, you've done a fantastic design, engineering, you did a CAD, or you did a drawing, engineering drawing, everything you made. Then it has to be produced as a part. The parts can be manufactured in various methods, but predominantly industry uses these 4 types. Ravi, my voice is clear or it's loud? Everything is enough? Sorry, I'm just
fine,
checking it.
It's fine. It's fine.
Yeah,
It's
yeah.
fine.
Sorry, audience. I'm just doing checking whether my voice is correct and everything. The first foremost is rapid prototyping. It's called additive manufacturing. It is there for almost 20 years. People said when additive manufacturing introduced, it's going to take over the world. Absolutely fine, but I can say maybe 10%, not even 10. We hardly 3% of the parts is being produced using rapid prototyping, additive manufacturing. The reason why additive manufacturing is little limited in application is one is it takes longer time to produce a part, and strength-wise it's a challenge, because initially they started with the plastics, then it started with a sintered material, then finally now materials are into the place, but still it takes a longer time to produce. Then the metal cutting, I can say it's around 70% in the industry they use metal cutting. And let me just show one small video of what is the latest trend. We all call it 5-axis and everything, all latest technologies, if you could take it. And if you take 5-axis, generally people do the still roughing with a basic 3-axis machine. And in finishing application like 5-axis, you cannot give a more load. It's only finishing. So these are all some common thing which always you cannot eliminate still 3-axis. You can keep it 5-axis, but it is very important. You can still keep basic 3-axis machine, because you cannot give a more load. Imagine all this 5-axis, which all the clutch will be free. So that's very important. People, when you are into modern manufacturing, you have to be careful, and you have to do always remember that some basics always. The third method is metal forming. CNC punching, turret punching, a lot of progressive dies, and that could be additional another 20% of the market it's being doing. Today, the latest technology, it's called hybrid manufacturing. I can call the marriage between 1 and 2. It started coming. And now Europe, it's very famous, and very soon you can see it in everywhere in the world. And that's what I'm going to just show you, take it, how the concept works. Earlier, both have been separate. Now they married both. And it's called hybrid manufacturing. In this, what I'm doing is using additive method, I'm adding the blades. Then I'm doing a machining. How easy it is. Earlier, people used to do, this is a conventional method, people call it. In wall industry, they used to do this. Suppose if something is wrong, they do the add material by welding it. And always I can say, we are human are very good actually. For now, let me just see that this is explaining, adding the material, then the tool change the same. You have a different head. Now it's doing a machining. So this is called hybrid manufacturing. For there is a lot of investment, or I can say a lot of R&D is going on this, because this this moves the way in which we are manufacturing the part. Because earlier, as I said, we have to go work in the boundary. We cannot call mechanical engineers always. Still, we have to work in the boundary because we need to work on what are the machines we have and all this we have to do. And just imagine, see this, it's now adding material, then it's removing it. It's further, I'm showing maybe the example. A lot of now machine tool builders started doing this research on this. And there are some challenges, definitely. But all this we have to overcome. The future is going to be hybrid manufacturing. Today might be, it's around 5 to 7% it's contributing. Future, you can see it adds more into the conceptual age. As I said, we're all into the conceptual age. Just see, you are adding material and removing material. Let me just show, not too much time on this. This is a concept which you would like to explain. Then let me just show the outcome, finally, how it's look like. The part. I'm moving this. See, this is the part. Imagine this part has to be manufactured in the traditional method. It takes time, and that's what people always introduce, this hybrid manufacturing. And as I said, this maybe contribute the balance amount of 7%. In the people expect this 7 may grow in future. It depends on 12% to 25%, but it depends on how the industry takes or what are the industry challenges. For at present, CNC machines are doing the major role. Now, if you want to produce a part in CNC manufacturing, what are the steps? So this is the 4-wheel, I can call it. Somebody is trying to say that, you can try anything, but if you want to do a new product development well, you should have a 4-wheel. Out of 1 wheel, it is going down, you cannot produce a part. This is a 4-wheel in a car, likewise a car or any moving object. You need this. First is process planning, and the second one is fixture design. The third one is cutting tool selection and CAM and SOP. Let us go in detail. Let me just put forward new product development challenges. I put this is tip of iceberg. The reason is, you can generally see if you are running a factory, or if you are running a MD, if you are running a factory, or if you are working anywhere, people will see the outside. Okay, on-time delivery is a challenge. Rejection is a challenge. Whenever customer is asking product by tomorrow, when you are unable to supply this, then you have unforeseen reason for this. It's not like something wrong. If there is a rejection in your NPD, there are rejection. There are reasons. Unhidden, like as I said, tip of iceberg, you can see all these errors. Process planning error, more setup time. That's the reason you are delaying the part, and unexpected accidents. Imagine sometimes it go and hit. Oh, it's a challenge. And what happens, some sudden accident happens. Even if human being, if we got hit, even as an entire humanity now got hit by accident by COVID pandemic. How much time we are taking. Imagine same way, if the car accident, if there is accident in the machine, it takes time. For it is better to work very smartly to avoid this. That's where the objective of today, the webinar is, what are the common mistakes in new product development? It's many. As I said, many, and we trying to cover which are all the most common in the industry, and that's what we are trying to address it in another 90 minutes or 60 minutes, which we can go in drill in detail. For one is the process planning mistakes. If you take it, still now there is no automation method or technologies available, whatever, it's a CAD/CAM, Industry 4.0, whatever you call it, still the process planning has to be done by human. That's where we have been employed. Unfixed accidents during prove out, and longer setup time. But that's a big challenge. How you can avoid. Let me just start with one by one. We are trying to address all this, how you're going to overcome. That's the objective. I'm just trying to give it to my colleague Ravi, who is joining from Bangalore. Ravi, sir, is it possible for you to take over the session, which I can move the slide for a couple of minutes?
Definitely, sir, definitely. Thank you, sir. Thank you for the opportunity. So I'd like to say about this one. It's a simple flange coupling, which you can see in any common valve application, as well as day-to-day activities in the regular manufacturing parts. So in this particular drawing, how we need to plan the processes, you can machine in both the ways. Like you can do the top side as first setting or the bottom side as first setting. That doesn't matter. You can machine the part. But before deciding which side to be machined first, you need to see the drawing carefully, and you need to understand what are all the important GD&T symbols that are given here. You can see here datum A is given, so that is going to be the key here. And with respect to datum A, they are trying to control the bore as well as the ID groove in this side as well as in the bottom side as well. So in this area, what I would suggest is, since datum A is given as the top side, I'll be machining the top side first, so that I can machine that particular area. You can see here in the simulation, you can see, I think it's the wrong one. It's done in the other way. like the opposite side is done first, and they are measuring the datum A in the second side. Of course, you can measure the part and you can manufacture the part. I'm not saying it's not possible, but the thing is the repeatability and the confidence which you are getting with the part, like get it right first time when you are machining the part. That will happen only if you are properly following the GD&T symbol. So when the datum A is given here as tightly tolerated, I'll try to measure this area, and during the same setting, I'll measure this bore diameter 86, which is also concentric with respect to datum A, and I'll measure the grooves which are all given in the detail C. That is diameter 96 mm groove. And in second operation, I can grip using the soft jaws, the datum A, and I can measure the opposite end so that I can make sure that the diameter 80 mm is also concentric, as well as the grooves which are all given in the detail B is also concentric. So this plays a key role. If you are doing in the opposite way, what will happen is the entire process will get upset, and there is no assurance that all the 100 parts or 1000 parts which you are going to manufacture will be produced within the given concentricity.
Yeah,
So
Ravi, can I take always there is a guidelines that wherever there is a datum that has to be machined first. Am I right?
Yes, sir. It depends upon the relativity, like a relationship, how it is being established. So this is like a key. So once you control the datum first, then with respect to datum, whatever the dimensions are given, you need to use that datum as a gripping point. So with respect to that, you are measuring the other related features, and you can make sure that your part will be manufactured at the same tolerance value even for n number of times. So this is like a basic step which I can say you. Similar to this, each and every part, perpendicularity symbol and other GD&T symbol needs to be observed very, very carefully, and accordingly you need to plan the sequence of machining operations so that we can ensure that the part is manufactured without any issues. So this is very important for for process planning, that GD&T needs to be properly interpreted. So we need to be well equipped with the GD&T symbols.
Yeah, thanks a lot.
This is the right process, I think, sir. This is the right process which we defined.
Ravi, thanks a lot. Thanks a lot always for giving this tip of what I can say iceberg. One the gray area which we found. Say what happens is still there is no automation method or available. Human has to understand the drawing, and whether you are from Kenya, whether you are from Japan, whether you are in the world anywhere, the beauty is it's going to be only two standards is being followed. Am I right, Ravi? Maybe if you could give a through on this. Anywhere the drawing is same.
Yes, sir. It's same only, sir. There are two standards. One is ISO and another one is the ASME. So these two are the standards which is guiding the GD&T completely. So everyone will be following. In US, they are following the ASME, and the rest of the world are following the ISO. Both are almost closer together. And once if we started following this standards, obviously you can read any drawing whichever created internationally. You will not see any differences at all.
Yeah, fantastic. Thanks a lot, Ravi. Once again, as I said, it's very important for us to study the first important thing, which common mistakes as in a new product development is process planning mistakes. There is no other way. Ravi, is there any other way we can use some software, or is there any other technology we can use? We can do that, or only human has to do?
Like process planning can be automated, sir, but not for the first time job. Like if you have a repeated job, similar parts, I have a flange A and similarly I have a flange B, everything will be same. Then you can create some template and do it, but we can't expect that to happen every day.
Information Ravi was involving in working with earlier the company name called British Engine, and Ravi, if you could give a few thought, maybe a few words, then we can move to the next one.
I was working in British Engines. It was a valve manufacturing company, and for the last 4 years they started manufacturing heavy engineering activities. So we started widening our scope. So we used to see day-to-day activities like nuclear, solar, everything was involved. So you'll not see anything repeatedly. Initially for valve we were able to do some standardization. I think it was up to 2016 or 17. After that, they started widening the area, and we couldn't find any repeatability. Even I was working with Lakshmi Machine Works in 2005 to 9 in Unit 1 LMW.
Yeah, fantastic, Ravi. So what we are trying to say is the process planning mistakes, it can be avoided only by the human, and for that you should have a skill set of GD&T. You have to thorough, because that's a basic which Ravi was trying to put forward with his experience. He's trying to say for the first time which we ought to do that. Maybe the similar type of components we can follow the same copycat, but the first time in any new product, and we are going to lay the road. That is very important, and it looks very simple, but that's a basic fundamental mistakes which we can do that. Let me just put forward, as Ravi put very clearly. Next, we are moving to the topic of today about fixture design. It's a common myth about fixture. People always say fixtures are used for mass production. It's batch production can be managed with standard clamps and machine wise, whether it is I'm doing aerospace or I'm doing different thing. Whatever you call it, I don't need the fixture because it's single part doing a fixture. It takes time and takes more time, and fixture design is very difficult to learn. We are going to break that concept into another 10-15 minutes, how easy it is. And with me, even a couple of my other colleagues also there, I'll try to pull them. And that's a common myth. No, let me just put forward what are the challenges if you use a standard C clamps. Always people say, if you are failing to plan, you're planning to fail. That's very simple. The same way, the first and foremost step, very important, is if you are into complex manufacturing, or if you're into aerospace manufacturing, if you're into thin wall manufacturing, precise manufacturing, or very expensive material manufacturing, you need a fixture. Let me just explain you. If you are using a standard C clamp or maybe anything, what will happen? Imagine this is the figure. Let me just start with Wise. I'm trying to manufacture this. Finally, I'm going to show you how it can be done easily with the fixture. Now, this on Wise, I'm going to clamp. In a CNC machine, in the Wise, I'm going to clamp. It looks, oh, good, doing operation. I've been clamped. It's doing started drilling. After some time, what happened? Oh, unfortunately, patient died. Operation success, patient died. The component tilted. Because that's what will happen if you are started using, okay, Wisers is not good. I'm going to use some standard C clamps. Then I'm trying to hold this component like this. Then what happened when I'm trying to do the drill, the component may try to move around, because in a hand how much you can tight, or there are possibility that the peak point, say here what it's happening is only the peak point I'm trying to touch. Now I found, okay, now I started doing a drill, then it started rotating. Okay, now I'm going to give more force. Okay, I've done more turn. Okay, what happened? What happened? You can see the mark on the component. If you are trying to tight more, this component is a little less wall thickness component, you will have issues like this. This we did it. Maybe for one of my colleague here with us, our partner Alexander, I'm just remembering when you're trying to do the operation, then finally the component got twisted like this. Even you are trying to grip it on the standard, it's a thin wall component, we're trying to grip it on the lathe without fixture, this has happened. For what we're trying to say is, whenever you are manufacturing a new part, say goodbye to all standard clamps. Wise, please use fixture. Fixture is no more difficult to learn. Another 15 minutes, we are going to see how easy it is. You can do the fixture. And once again, we are going to show how easy it is. One is, first is, when you are trying to use the standard clamps, surface flatness will not be good. You have to use dial, you have to adjust it and keep dialing. And it's a cumbersome process. And every time different location. We are a human being. And when I'm trying to load the component, I'm trying to put forward. First time I'm trying to load it here. Second time I'm trying to load down. For it is very difficult. Exactly the same location every time doing is a challenge. And similarly, it is very difficult for you to write a program also. Whether you are using a manual programming, whether you're using CAM programming, when the position is same only, you can do repeated machining. And finally, you can do ulta loading. It's called no pokeyoke. And I'm going to show you how you can all arrest it. Pokeyoke means you can load the component in ulta way also. Or it's a common, it's a Japanese word again. Everybody knows pokeyoke. It's a foolproof method. And the final challenge is more loading and unloading time. So what I'm going to take away is, whoever is attending this course, henceforth, any part you are manufacturing, please you can take even 3 days or 2 days, you develop a good fixture. Today, technology can be manufactured. Earlier, I'm just sharing, to build even one home construction, it takes 1 year. Today, and all, you can do it within 3 months. There are technologies available, machines are available. You can dig it. Likewise, today technologies are available. You can produce a part very quickly using all this technology, whatever I said, whether it is rapid prototyping, whether it is additive manufacturing or metal cutting, metal forming, everything you can do that. Let me just put forward now how you can do the fixture design and easily.
Sir, sorry to disturb, sir. Can you share the screen, sir, because it's not visible.
Oh, just now it went, or? Oh, sorry. When it got, Ravi, it's fine?
A couple of minutes before, sir.
Oh, sorry about that. Thanks, Ravi. It's now clear?
Yes, sir. Now it's fine.
Okay. Are you able to all, please, whenever it is a little going away, please let me know.
Yeah,
Ravi.
sure, sir.
Yeah, yeah, please, please. And say, what we are trying to say is, if you want to overcome all this, when you're trying to produce a part, uh, whether it's expensive or anything, today technologies are available. You can produce a fixture at very within a very short span of period. I'm having one of my friend who is a manufacturer of fixture, Mr. Alexander, WW Engineering. Can you please say any fixture how long you can take a time to produce? Sorry about it. If
Hello.
he's,
Yes.
yeah, yeah. How long you can take one part to produce a fixture?
1 week.
One
Around 1 week.
fantastic. Yeah, that's it. If, what we are trying to say is definitely within a week, if you are able to produce a fixture, whether it is a complex or medium range, or today you can pull the resource, but the first time it will be right. Let me just put forward what is the purpose of fixture? Say, I can say today the objective is how you can do the perfectness. The concept is very simple. You have to whether if you are using a manual clamping, there are different types of clamps are available. I can say fixtures are available. First is manual clamping. The second is hydraulic clamping. The third is magnetic clamping. The fourth is vacuum clamping. The fifth I forgot, but still pneumatic clamping. Predominantly widely all this been used. Whether you use vacuum clamping, whether it is a magnetic clamping, whether it is hydraulic clamping, all these are this three basic purpose. If you are doing, always people say when you are playing football, if you lost the match, you have to always go to the basics. Why? There is a basic reason. The same way, whether you are into these 5 types of fixture types, the first is easy loading and unloading of component to be mentioned. If you are trying to do too much complex things, if you are unable to load or unload the component, what is the fun of it? The second one is perfect positioning each and every time. Whenever I'm loading, I'm trying to position, I'm going to show you all this. Whenever I'm trying to position the component, it should be always poker yoke. I cannot do in a wrong way of loading. The third one is at the end, what it is very important during machining, the component should not get damaged. It could be more clamp, it could be any no accident due to wrong design of fixture. That's a basic 3 benefits which you are going to see that. Now I'm going to address it to you what is the simple or way of doing it. As I say, concepts remain same, whether it is you're doing an aerospace part, whether you're using a automobile component, whether you are into textile machinery, whether you are into heavy engineering, whether you are into precise manufacturing. Fixture design concepts are same. How engineering drawing is same. The same way concept of fixture design is same. Only the way of clamping is different, but the basic fundamental, there is a concept name called CLRO is same. Let me just put forward once again. I'm trying to highlight the fixture design. The basic, the first and foremost step is drawing study for process planning. First of all, I should know, read the drawing. How many steps I can do that? This is a drawing, basically. Since I'm not going to in detail, as Ravi already explained one thing, explained in detail, I don't want to dig in detail. You're all engineers, you know how to do this. And I need to take reading the drawing, compare with casting, whether it is a raw material can be a casting or it could be a boss stock or whatever you have to compare, and the X and Y and or maybe input and output material, you are going to decide what are the operations I can do that. The first is process planning. Then I need to plan a machine. You cannot ask if you have an apple tree, you cannot ask for orange tree. Sorry. Same way, if you're having 3-axis machine or 5-axis machine, you cannot ask turn mill. Whatever you have in a company, that you have to do the process planning within the limitation. I cannot ask, so this part, if you want to produce tomorrow, I can do it if you give me a turn mill with C and Y axis. MD will fire you on the same day in the same company. So everybody cannot be perfect because we have to work in the limitation. And likewise, first of all, the selection of machine, the second step is very important for fixture design. And for what we have to do is we have to see what are the operation you have to perform. In this case, there is a 10.5 mm, this 4 holes I'm going to drill, and similarly this dia 4 2 hole it has to be done. Then this particular drill come tapping you have to do. But can we use the same machine? That's $1 million question I'm going to answer. If you have a 4-axis machine, you can do it within a single setup. If you're having 3-axis machine, you have to do 2 setups. That also human has to decide. And let me just go in detail. Type of fixture is needed, as already I pointed out, and how many fixtures you need. If you have based on the machine, the first is your process, then the machine, then you have to decide based on the machine. If I'm having a 4-axis, all this operation can be clubbed to one setup. In case if I'm trying to do, if I have only 3-axis machine, I cannot ask my MD, please invest 5 lakh, sir, additional 4-axis rotary table. I can do this. Then it is a stupid thing. And that's what we can say. Now we can go it with 2 steps. Now we are going to do the fixture, which is going to do this 4 drill and this 2 drill. And I'm going to go ahead with concept. Clamping can be done anyway. The same can be done with hydraulic clamping or manual clamping. In this example, we are trying to take manual clamping method. As I said, if you want to master fixture design, you have to do, there is a 4 concept. If you design, if you address, then it is everything is fine. I'm going to address one by one in the next slide what it is. I'm going to leave 2 or 1 maybe into the suspense. You can find it out, maybe your choice. Let me just put forward. The first step is L. L. Any maybe a chart I can see. What is the L? What is the L for fixture design? What is it? Maybe you can chat box. You can type it. Ravi, you can check it out whether it is correct. I'm unable to see the chat box. Okay, let me just put forward. Still, you can see that the answer is. Still, you can put it. So this is basically any
leveling.
answer.
One answer is leveling. Shantalingam has mentioned as location.
Wow, that's a good answer. That is called location is a correct, fantastic answer. Shantalingam, that's a good answer. You did it. Let me just put forward. If it is basically a location, what I'm going to do? Say, as I said, L is for location. I'm going to locate the component, and now how I'm going to load it. When I'm going to locate the piece, is exactly it has to be rest on this bottom, and same way easy loading and unloading should be there. If you look here we have given some relief, because if you're trying to give a round, because it's a round part, if I'm going to give a round bunk, then every time you have to say somebody, I don't know how many of you know, if you're trying to do the thread, if you're trying to with a hole and thread, if you're trying to fasten, it's very difficult. Same way, if you are giving a full round, then you are trying to enter every time the component, you take few seconds, but it leads to problem. So that's why we are given a relief in this. If you look here, the location should be very easy, very smooth entrance. It has to be done. The first answer is L is location. For you have to load the component, you have to give enough relief angle, and wherein which your component can be easily loaded. So that's the first principle. And the second one is O. Any answer from the group? Well, I can do in various methods. Let me answer this. Orientation. O is once again orientation. How I need to orient the component. I can do it in different way. I can load like this. I can load like this. How I can going to stop? As I said, it's very simple. First is location. As I said, in the location I loaded, then exactly I rested on this. I spotted, because when I'm trying to do the drilling of this, I need to start exactly from this. Therefore, I need to properly every time whenever I'm doing, whether I'm closing my eyes and I'm loading also, it has to be always but on the bottom. So that's called location. Orientation is, as I said, there is a possibility that it may go in various direction. It can go, I can load like this. How can I arrest it? Now I'm going to show the answer. This is called orientation, and this we have introduced Pocoyoke also. If you could introduce here, I can load perfectly. I'm just trying to put a stop. Here we have introduced V block. Maybe I'm just trying to put, yes. If you could look here, are able to see, we introduce a V block. Then you can load only, look, say the orientation, it will be always this particular, you have to look, if I'm, you can use V block, you can use a round pin. All this is a very innovative method. As I said, you have to address L, location and orientation, you have to address. How I can do the orientation of this round cylindrical part? I can use V block, I can use U block, I can use like this. And even if it is a machined part already, I can even introduce here some padded nylon or HCSCR padded. I can use it. But in this case, its component is, if I'm not wrong, the component is this is maybe MS. Then no, I can go ahead, or maybe ENite. I don't know what is the material. I have not looked into this. Then it's fine. So what is very important, as you can see here, this is basically on location. It has to be exactly but on this bottom, and easy loading should be there. And we have addressed both, and giving a relief, and the V block we have introduced in this case, and then I have done it. If you are not introduced this pin, what will happen? I'm going to show this. Why we introduce this pin? It's called Pocoyoke. This looks very simple, but as I always say, for a complex problem, the solution is very simple. Just trying to put. Now I did correctly. How? I'm a fool. Sorry, by mistake I did. I'm trying to load this. Will it complete? No, you cannot load the part. It is the pin will stop you from doing wrong way of loading it. Of course, people can say that. Why? I can also introduce one more pin here. I can introduce one more pin here. If I'm not wrong, you have to introduce 3 pins basically. Because generally why I said this, and the common mistakes is the people can load in 90 degree. That's where I put it. But if it is a wise man, still you think your people are very new to the business or new to the machining shop, then you can introduce 2 more pins also. That's what concept, and which we can do that. Now I'm trying to do this. Loading perfectly is being, this is called foolproof method. You cannot machine it. Oh, you know something, oh, it's not butting. And then it's fine. So this is the right way of loading, and Pokeoko has been introduced. So let me just, sorry, I'm just putting it keep, then I can introduce the further. Now, how it can be done actually. So as I said, today technologies are available. A lot of CAD/CAM started playing the major role. I don't know design. Once my concept is right, then I can check my concept. No need to go and do the trial in the machine. You can do the trial in the CAD/CAM itself. In the computer itself, you can do that. Now it's going to do the drilling accident-free. As I said, one of the major problem during the trial is accident. It's happening in the machine. The reason is maybe my wrong fixture design, or maybe my tool holder may hit here, or maybe all this you can overcome. For in this case, which I'm trying to do the manual clamping, which is called C washer, which I put manual clamping, but you can do whatever the way you want. You can introduce hydraulic clamping, you can introduce vacuum clamping, but the concept remains same. For now, I'm trying to do 2 drill. We're not gone much about clamping, and with the other one, or is always I have not answered. Or you can think of it, what it is, you can search it in Google or anywhere, or otherwise you can come back with us and we'll answer you what it is. For the fixture design, there is a 3 concept is available. L is for location, O is for orientation, C is for clamp. The clamp only decides the way, manual clamping, hydraulic clamping, and I'm going to show you next how hydraulic clamping can be done. So this is a way of doing a design. Now I'm going to show you what is very important. Now I made a design, concept design I made, that has to be proof of eating is the food. If you cook something, you have to eat. The same way, if you've done a fixture design, you need to know how to do the manufacturing drawing of the fixture. The first and foremost step is you have to do manufacturing assembly drawing. That's a basic, and there are everyone should know how to do the basic assembly drawing. Then a part drawing you have to do. If you look at this, even for base plate, you can see how much. Sorry, I'm trying to zoom it. Oh dear, it's not happening. That's fine. I'm trying to zoom it little. Okay, fine. It's fine. If you could look here, I put this a datum as Ravi mentioned. Oh Ravi, even in fixture design also we are using all the GD&T. Ravi, is it necessary?
Definitely, it's required, sir. For any manufacturing part, it's required, sir. It may be a fixture or a component.
Just for making it fun, I'm introducing Ravi, and it's thanks a lot, Ravi. It's if you look at it, even to manufacture a base plate, I need a datum. Please, overall, you look very simple. Even for fixture manufacturing, you need to do the proper planning. Why it is, I've introduced this datum, here grinding symbol, there grinding symbol is, I want to load every time in a correct position. Because if you look at the here, whenever I'm trying to load this part, it should be always, it should not be little, like I can say, it should not be like this. And component will rest only this part. You have to, every time you have to load, if you're loading 1,000 times, 1 lakh time, it has to be the same. And that's what very important. You have to do the grinding here and grinding here. What are the further assembly part you have to do? You have to follow here. There's a symbol of again parallelism. All this you have to maintain. And let me come forward. Maybe I'll not explain the much other part. Let me just put forward a V block, because in the orientation, which we said V block is very important. See how important it is. Here is also grinding symbol, because straight away it's going to come and assemble here. And the same way, if you could look here, the material plays the major role. Fixture parts, material planning is very, very important. If your component material is aluminum, then the V block material is different. EN24. If your component material is titanium, you're into aerospace, and your component material is titanium, that's it, very simple. Fixture design, whether it is aerospace, whether it is precision, the first and basic most is, depending upon your component material, the particular fixture part, because it's going to, why we have to select this material? The answer is very simple. It's going to be wear and tear. If you could look here, if you are driving a car, after some time you have to replace tires because tire is getting worn out. That's a very simple example. The same way, why if you're running maybe 40,000 or 50,000 kilometers, people used to change the tire of the car. Same way, if you're trying to load the component, definitely every time you're trying to load the component, this part may get worn out. If you're using a soft material, what will happen? Very soon, it will not even come up to 50,000. Why people are using rubber material or maybe threaded, all this in car? Sorry for explaining with a simple example. I won't explain with the day-to-day example. So therefore, it is very important whether you are into any manufacturing. People think, oh, aerospace is definitely it's a complex part. Design is a complex one. The manufacturing is the same. But what is very important is if your component material is titanium or aluminum special grade, you ought to put, imagine that I'm going to use maybe n number of time, I'm going to use a V block, or you may think I'm going to use only 2 times, 3 times. Can I use soft material? I'm going to ask you the answer, Mr. Alexander. Are you there? Are you understanding my point?
Yes.
I'm into aerospace. I'm using titanium material. Why should I use EN31? Can I use soft material MS? It's a bit cheaper. Why I should do hardness? Do you have an answer, or you want me to answer? Okay.
I don't know.
Oh, okay. Sorry about that. Say the reason is very simple. Whether it is why we are trying to do is you can introduce MS. Whether if you're into aerospace manufacturing, you always assume that the part you can use soft material. The challenge always what happening is it is better to use. If it is for titanium material, better to use V block material is EN31. The reason is very simple. Nobody can say that I'm going to throw it off this particular fixture for after some time. It may take some time. You can do the trial first time, see how it is coming, and if it is working fine, you can use still soft material. But if you're going to use more part, then better to do the good EN31 material. No need to do the heat treatment. If you are trying to do more part, then please do the heat treatment. But that's what we can say it. Heat treatment also plays a major role. And whenever you are into whether it is aerospace manufacturing or whether you are into any manufacturing, use some what I can say technology. Today Google is available. Search it or use some common sense or do practical and experience standardized. Say what happens is when earlier I was working with Rani and Locust TVS, we are learning from mistakes. And whenever you're making a mistake, what happened? Please try to record it and do not do, because you are into the pressure of producing a part very quick. Customer need a part yesterday, but you have to use some common sense at the time. By answering this, why I'm asking all this question, why I'm trying to answer is to put forward we are the designer, we are the learner actually. So let me just put forward the next one. What is the modern way of doing a fixture design and checking? Let me just put forward. This is basically a engine casing, and it's the primary purpose is after doing all this machining, people used to going to do honing fixture. It's basically the purpose of is I'm preparatory for honing application, and which the people are going to do is engine, very complex machining. They're going to do honing. Before that, I'm going to do all this. The first step, as I said, the fixture design is loading and unloading of the part. Today, using a CAD software, you can check everything whether I'm able to load the part without any difficulty. As I said, this is a modern way of checking. No need to do. Earlier, people used to do the checking in the machine shop. I remember when 20 years before, when I was working with Rane Madras, I used to spend a trial itself. We spent 3 days. Fixture throughout 3 days. Then we used to do a correction. Today, no need. You can check everything in the CAD/CAM software, and you can simulate. My entire process is correct, and our ultimate aim is first part right. But that's very important. Let me just put forward. I'm trying to see what happened this basically. Yes, I'm trying to see the simulation. It's a little bit run it. It's very big one, and just to check whether it's trying to do this machining. If it's hitting with this particular clamp, you can decide. Oh, there is a wrong, and all this you can check it out in the today recent, or I can say any CAD/CAM softwares. And that's a beauty of today technology, which in front of us we are having it. Let me just put forward. Likewise, you can keep doing it. I'm doing all the steps, all the side rotation, everything you can check while rotating, whether it is hitting with the part, all the accident free. Once you do the checkout in the CAD/CAM software, you can be under, that's called digital world. People call it, we are into the digital world, digital twin. No need to do the trial in the machine shop. Any new product development, spend more time in the computer. and you spend very less time in the machine shop. And that's what we are trying to do. Whether it is fixture design, anything new product development, this is a very key role. For once I'm doing, every operation is being done, I can check here itself unloading of the part. I done everything. Now I'm going to see whether I'm able to unload. So that's on manual clamping way of method. Next, I'm going to show you hydraulic clamping. How hydraulic clamping is done. So now I'm going to this particular part. I'm going to do simple face milling. You may think, why I should do the fixture? But the problem is, this is very important, is you have to maintain the flatness within maybe say, 10 micron. Then you need to have these fixtures. And imagine how I'm doing a clamping, step by step, all the clamp for, but it will be all simultaneously clamped for demo purpose, which we have done it step by step. Let me just put forward. I hope so you can all able to see this. I'm just trying to see this. Let me run one more time. The first is this one. It's ticking. That's then it is coming. Okay, parallelly all are coming, but all will come simultaneously. So there are purpose. Here also, once again, I said whether it is a hydraulic clamping, the concept is same, CLRO principle. Once again, location, orientation, clamping. This time I'm doing with hydraulic clamping. That's fine. Still, or I am not answered. Or please, it's open question. And we can move forward. So let me just put forward, this is a modern way of manufacturing. And now I have done loading and checking. See, you can see oil flow, how it is going, which cylinder it has to be clamped. All this you can check it out today with the technology. Now I'm going to do machining, how it can be done. Very simple. And this part can be machined and seen how it's going to do. Whether when I'm trying to do the machining of this simple face milling, whether it's going to interface with this part, any of this part, all this you can check it out. And that's modern way of doing concept to perfectness. I no need to do the trial in the shop floor. Ultimate aim is we are doing everything on the CAD/CAM solutions. And let me just put forward what the next part is, which I'm not going to cover much about cutting tool and CAM, because time is also already, we are 50 minutes. And cutting tool, always one word I can always say, please always use, never ever, wherever possible, try to use requirement based cutting tools. Always what happens is today, somebody vendor will come and supply. No, you ask, I want always go with special. How I'm different? You have to question status quo. When was the law change made? And change, you should do that. You are the change point, not like other vendor. You say, I need this. You ask anything in the world, you get it. That's very simple. For you can think always, I need a special. You imagine what is impossible. Somebody today, imagine, anybody can imagine people are trying to go to moon like a tour. Same way, you can ask. You're not asking, very simple. Therefore, you try to always look forward for combination type drills and so much of things which you can do. Today, even people call thriller. I don't know how many of you know this tool name. Anybody answer what is the meaning of thriller in the group? The tool name called thriller. Ravi, anybody is answering, Ravi? Or you want me to answer?
No answer, sir. You can answer, I think.
Okay. Drill. I can say chamfer, then thread. 3 operation called thriller. Sorry for just making it. It's available. Tools are available. Okay, now coming to CAM, whatever you explained much about CAM, today every company started using CAD/CAM, and SOP is basically standard operating procedure, how we are going to load it on the machine. Now let me just put forward the next agenda of the topic is setup time. Now I did everything. Design is over. I manufactured fixture. Before manufacturing fixture, what's going to happen, I'm going to show you. Typically, if you are into the process, first is you have to do the component clamping using a C clamp or standard clamp. You have to do align. Oh dear, he's trying to use like some. Sorry if I tell like that. That's where it's happening. Then tool setups. You have to use paper, adjust all the tool. Then you have to do once again manual offset. The big challenge is casting variation. We are not a human being. It's not a god. I cannot manufacture the part 0, 0. Casting, there is a variation. And whenever we are doing a manufacturing itself, we manufacture 5 micron to 10 micron part in CNC machine. Imagine casting, they do sometimes 1 micron or 1 mm also. How I'm going to take care of all this? That's a big challenge. And these are all the questions to be answered. And similarly, what we are doing is we're trying to do the part, then check it out in the CMM or maybe the outside the world. You use gauges and come back and try it. That's a big challenge. Today, that's a current, as I said, this is a big headache of CNC machining setup. Now I'm going to show you modern way of doing it. The first step is, if you use fixture, almost your headache is free. First headache is free. Or aligning, I can put still it's auto aligning. So, sorry for it, purposefully I have not written it. You no need to worry about aligning. The next is tool offsets. Imagine this particular part, the tools, if you use, there are tool setting probes are available, which it can be fitted like a cutting tools in the machine. I hope so. Most of them are using it. And, or if you're not using it, it's a modern way of doing it. No more human intervention is needed. You use this type of tool setting probes, wherein which all the offsets or where offsets can be managed by the system. It's a simple electronic device. It's a transducer. The simple transducer. Very simple transducers. It does the very fantastic job of monitoring. If you have 100 tools, if you have 200 tools, it manufactures the data. It give automatically offsets, get updated to the machine. Goodbye of manual way of taking. It's called auto tool offset. The next method is, okay, very interesting part is automatic work offset and in-process inspection. I'm going to show you, as I said, some of the example, what I'm showing is some of the customer examples is for educational purpose, nothing else, just to give you the idea. So this is one aerospace component, and the big challenge is the moment you are taking out of the part, done. You cannot fit it one more time, because this is, once again, you can see that typically they're doing it in a 3-jar check. And if you want to do the correction, not impossible. For what we are trying to do is, it's doing first is in-process inspection on the machine. If your tolerance, component tolerance is about 10 micron, very easily you can go ahead with in-process inspection. You save a lot of your time. I'm going to show you a couple of case studies in aerospace, and this is also one of the aerospace component. It's just, as I said, whenever you are trying to do in-process inspection, you are trying to do calibrate, because calibration is very important. It's doing a calibration. Then finally, it is doing, there are 3 operations it's going to do. It's a position tolerance it is checking. There is one hole is there, and here is other hole. And then I'm going to show you how it is works. And just it. After the machining is being done, you are going to do the testing of this and see the result. Wow. Oh, there. I'm trying to show this. Oh, sorry. I'm just going to show the result. Imagine we are into the world where after the machining parts is being done, you can see the result. How much is the tolerance? That's a world we are here. For what is very important, the concept of in-process inspection, and you are getting exact report attached to the customers. I still have a requirement, some of the customer who manufacture some of the critical airjet parts, I'm going to show you in aerospace. You can submit, because people say, I don't know how many of you, even if you get a small part. I recently bought mosquito mat, because I'm in my native place. Due to pandemic, I moved, and a lot of mosquitoes, even they put the quality checked, okay. We are very happy. The same way, imagine if you are producing a part, you give 100% quality satisfactory, then you will be very happy. That is possible only with in-process inspection. And today, technologies are being used. Now I'm going to show you one aerospace example. Again, I said this is for educational study purpose, nothing else. And please, I can say BBAT Aerospace will allow me to show this concept. Whenever, as I said, when you're using a thin material, thin wall, there is a challenge. Always it try to deform. Whenever you're trying to clamp in a 3-jar, or I can say if you're in VTL, if you're trying to put it on without fixture, there is a challenge. And the problem is, again, as I said, once again, thin clamp, people, I don't know how many of you know the process. Somebody, when you're trying to clamp and declamp, the component may also try to shrink and expand. Sorry for telling this. If your thickness is 1 micron, maybe 1 mm or 3 mm, it's a challenge. For what we are trying to do is this, as I said, the BBAT manufacturing company, they manufacture turbine rings. This is a turbine ring. Turbine ring for jet engine, and they're using it on one machining center. They're using with touch probes and software, in-process inspection software. For what we are trying to do is, once the machining is being done, then using online inspection software, we are going to verify the tolerance. You can give the bandwidth of up to, maybe you can give a green is 10 to 15 micron, 15 to 20 micron, or maybe 5 to 10 micron is a green, and 10 to 20 micron is yellow or orange. Above 20, it's a red. Likewise, you can give it, you can check any correction without dismantling or taking off the component. You can do, because there are methods are available. That's what we can say. As I said, 1 second fixture is mandatory for all this in-process inspection. And this is a live aerospace. If somebody is attending from aerospace, please think of it henceforth, if after the machining is being done, do the inspection in the machine itself. And you can use any technology, whether but it's very important. There are today technologies are available which you can use it. Now let me put forward the next one. We all spoken about industry 4.0 or all in process inspection. What is very important is the skill matrix of the manpower, because as I said, some of the applications or operations you have to done by human. That's where human is existing. And if you look at it, wherever you are, please do the acid dipping test. And whether you are in R&D, whether you are in production engineering, whether you are in production, please see, this is the one which we collected from various customers. We did a couple of interviews with hundreds of customers, or maybe, I don't know, thousands. And our people, our team is prepared. Ravi, can you please give a little bit small highlight? I will take a sip of water.
Yes, sir. Yes, sir. Actually, this is the skill matrix which we developed, after discussing with many customers. And this is like a minimum requirement which is required for any department in the mechanical industry. So in that, if you can see GD&T will be like almost common for each and every department, because drawing is like a language of engineers and we need to see the drawings every day. So GD&T will play a major role in order to enhance the skill set. So to sum up, what we can say is, what are all the technologies which Mr. Ajit sir has discussed so far? To implement all these things, we need skilled manpower. So that is the ultimate aim which I can tell to you. Like in order to get the skilled manpower, we need to enhance the skill set of our engineers who are all working in our organization, so that they in turn they can utilize these processes or these latest technologies, and they can easily bring a lot of huge cost savings to the organization. So in order to enhance the skill sets, we have listed out few of the skills that are all basic requirements, and this I can say as a summary, I can say it to you, sir.
Yeah, fantastic, Ravi. Thanks a lot, Ravi. And same way, every organization you might run the skill matrix one, because human are the excellent resources. And always people can say your machine may become old. I'm to say that aged, and it's become damaged. Whether I am using my car, after 5 years I need to change the car. Or if I'm using a machine cannot be run forever. After 5 years or 6 years, you have to change the machine. But human, when they become aged, when they're having a gray hair like us, they will be an asset to you. But what is very important is, that's the reason, one of the reason we are joining hands with GKD ITR, and we are trying to populate all this. We will do GKD ITR and Createch services. We do jointly lot of exercise to improve, enhance the skill set of the manpower, try to identify new areas, how we can do the improvement in the area of skill matrix, in the area of skill enhancement. And I'm going to share it with you how we are going to do that. So what is very important is, say everybody cannot be expert. And it'll take one example I'm going to show you. If you are into production, or if you're into production engineering or vendor development, doesn't mean that you have to master all, but you have to know everything. And say if you're into vendor development, you should know, maybe let me take production engineering. You should be expert in GD&T. Whatever the drawing, 14 symbol, any drawing, whatever it, even if you make you to wake up in the sleep, you have to answer it. A new product development, whatever the complex part, you have to do the fantastic process planning, and how I can do, which is the first one, which is the second one, all this you are going to do. And if you're into production engineering, you must know fixture design, you must master. If you're into production, you can be high competence, you know everything. So what I am trying to say is, according to the department, if you could enhance your skill set to the level, the company also will grow. You can also grow in the organization. You can change departments. I don't know how many of you know this. When I'm working with Lucas TVS, I started my career, Rane. Let me start with my Rane. I started with basically R&D. Then 6 months, I had some challenges. Then they moved me to production engineering. After some time, there is one guy, there is a shortage for production assembly we have to do. Then I've been even done assembly. For what same way when I was in Lucas TVS, I've been moved to SPM design. For what we are trying to say is, always you have to keep updating the skill set. Whenever my productivity is gone up, when I'm changing the departments. If I am in same field for long, you know very well, you are into comfortable zone, then you will your productivity will start coming down. Sorry for telling this. Wherever you are, if you are into R&D, please try. You can change it to production engineering, or you can change it to vendor development. You can see the high productivity among all this. For this, generally big corporate, they used to try within every, I don't know, Mr. Bala, it's LMW practices this. Generally people, company changes every 5 years or 10 years, they used to change the departments. I don't know. Am I with you, Bala? Mr. Bala?
Yes, yes.
Yeah, that's the reason we and GKDATR, we are here to striving to give the skill set. We are, whatever we listed is very few. We are trying to add many. GKDATR and Createch, we have a solution for all this. Let me just put forward, as I said, all this, I'm going to show you whatever we have just showed, the tip of iceberg, maybe fixture design or NPD process or GD&T. They just explained very small in a 1 hour how much I'm going to do that, very little. For what we did is, we have been striving for the past 5 years, we have been developed e-learning portal. It's jointly with GKDATR, and all these courses which you have been available, we are offering this, whether you start with fixture design course, whether it is a hydraulic fixture design course, it's a self-paced course. You can learn at your own time, and we support regular webinars like this actually. And you can take it at your own time, and weekly 1 webinar or 2 webinars will be there. And like start with GD&T, fixture design, NPD, and 7QC tools, and many it will be there. And we are in the process of adding more courses which is needed to the industry. We have been working very closely with the industries and GKDATR, which you can move forward. It varies. What we can always say is, it doesn't mean that 3 weeks if you put, or 4 weeks, you have to complete it in 4 weeks. We give enough time. 3 months will give a time, and it's been certified by some of the courses certified by AICTE, and all these courses are certified by GKD Institute and Createch services. And now it's a time. Bala, anything you would like to add, Bala, in this? Then I'm going to put the final session of quiz actually.
No, the thing is, yeah, we're working with the Createch very closely, more than a decade, because the first CAM interface after MasterCam we have introduced with the support of EdgeCam. That has been incorporated with the 5-axis also. We have been giving a lot of programs to the various corporates. Recently with the Tata Electronics also, we have been initiated this CNC programming. So that way we have been to a lot of new programs. I think this webinar will be like an eye opener for all the manufacturing industries to take up this NPD process. We'll be coming up with a lot of webinar series like this. Please join us. Thank you.
Yeah, thank you. And
thank you.
Yeah, thanks, Bala. And now it's a quiz time. And Ravi, or maybe your team, Ravi, can you share this?
I have shared, sir. I have shared already, sir.
Yeah, I'm just trying to put forward this, and maybe I look forward for the. Maybe I'll just stop my presentation. Or maybe I will just stop it, Ravi. It's good to have a. Yeah, please. It takes a few minutes to all fill up you. And okay, fine. Ravi, can you please share, Ravi? I don't know where I can see this.
Which one, sir? Sir, I have already shared.
Okay, people have started filling, Ravi. You can able to monitor this?
No, sir, I don't have that link, I think.
Okay. Let me just check it out. Yeah, please take your own time. It's going to take a few minutes. I'm just going to show this one because it gives a lot of. There is a quiz is there. Whatever we have explained in this 1 hour, you're going to answer. You will going to get the mark also in this. And at the end, I don't know, Mr. Bala has kept some norms for certification, but I thought everybody will get it irrespective of score. Am I right, Mr. Bala? Based on the score you are giving, at the end they are going to know the marks, how much they understood. Will everybody get a maybe a certificate?
Yes,
fantastic.
Yes,
that's a good answer. Yeah, but however, please fill it up. You know where you are standing, and it will take hardly maybe 5 minutes. And this is where the questions. Maybe if I am trying to fill like you, just it's very easy. I'm just trying to fill this. And it's very easy. I'm trying to put this, and there is a questions will be there. Please take your own time. There is no no urgency in this. Then we'll be after this. We are going to have a Q&A session, and please fill this. And Mr. Bala was very particular. He called us at 2 o'clock. Am I right, Mr. Bala? He said, "Ajit, I want to run a quiz." Oh, and we need marks also to be displayed. Then I asked, okay, will the people will get certificate only if they're through? Bala is so generous. He said, no problem. Today he answered. So this is the basically we just entered. Then you have this quiz. All this quiz, you will be having this, and at the end you will get a mark. If you are secured above 70%, I'm very happy. Ravi, I hope so people can get this. If you are getting above 50, I'm okay. Okay,
others can enhance their skill sets. Sir. That's what it is. It is the time to revisit the basics, sir.
Yeah. Fine. These are all the questions. Please keep answering this. It's all MCQs. We are not kept. Initially, we had a thought of giving, you can you can add maybe type, or you can add descriptive answers. But Mr. Bala was very curious. Bala said, "No, Ajita, we want demand decides." 2 o'clock he called us and he said, "I need it has to be introduced. I need to see the results." Uh, I'm very happy, and please answer this all, and let me parallelly also see how many of you are answering, and let me parallelly put off my screen, then I can see the answer, because I cannot show other answers to everyone. That is a secret. I'm just stopping it for a while, then I will take Q&A once everybody started submitting. 1 minute, I'm just checking out. Is my screen is off, Ravi?
Yes, sir. Yes, sir.
I'll just see everybody's done. Then we'll take Q&A. Bala will allow for a few minutes, Bala, because it's some of the questions are framed. 1 or 2 are tough. The rest of them are easy.
Yeah, take your time. No.
Yeah, fine. Just allow me for a while. And I'm just checking out how many of them are answered. I'm going to share now how many of them are answered now. 1 minute, Bala. I'm just going to share it with you. Okay. Started coming responses. I'm just seeing it. Then once you're okay, then we'll take up Q&A, because it's very important. We should allow them a time before they're asking a question. And there is a feedback form also. We introduced very small feedback just to give you. Just we'll allow for a few minutes. And just we'll allow for a few minutes. Just allow for a few minutes. அஜிதா, எத்தனை பேர் ஆன்சர் பண்ணிருக்காங்க பாருடா. எப்படிடா பாக்குறது? நான் ஆஃப் பண்ணிட்டேன் மொபைல். அஜிதா கூப்பிடுமா. Oh, the page itself, it's yeah. We'll allow for a few more minutes, then we can take it up for questions. I'm just trying to see people have started filling up. Just trying to see once everything is done. Can you just check whether it is? I'm not getting the response. I'm not seeing it. Sorry, I'm just checking it. I'm on off video. Sorry, I'm just checking out whether everything is done. This is the one.
Yes.
I hope so. If everybody is done, then we can. I'm just trying to see. It's thanks.
Hello.
How many people are submitting at the same time? Yes. Yeah, please. We can now, Bala. If it is okay, then we can go ahead with. We'll wait for some more time. Few more minutes. Then we can take up Q&A. We are just checking, Bala. Everybody is done, because if on submission only, I hope so, we'll be issuing the participation certificate. That's the reason we are all waiting.
Hello.
Ravi, for you also we shared, Ravi. You can also check.
No, sir.
I don't know. Okay, no problem.
Only
That's
just
fine.
feedback form link I have received, sir.
Okay, no problem. I don't know. Maybe many people are filling at the same time. It's showing. Wait, I'm checking with other IT person. Let us 2 minutes. We'll see whether everybody is done. Then we can go ahead for Q&A. Bala, is it okay, Bala? Maybe we can wait for few more minutes. We'll see that everybody is done through.
Of course.
Yeah, because that is very important, because sometimes we have to give a due time for quiz. I don't know. We can show the answer. If you want, I can show them the answer. They will get answer also, Bala. What we did is, they will, after answering, they can even see the answers also. If whatever, all this we have been done good automated. Let us see that. Thanks, Bala, for this wonderful idea. We are also very happy. Come outside meeting. Hello, 1 minute. Ravi, are you able to hear my voice, Ravi?
Yes, sir. Yes, sir. Audible.
Yeah. Sorry, I'm just trying to switch on the video, or maybe we're just checking out. Please hold it. I hope so. If everybody done, they can raise a hand. Then we can take it up Q&A.
Yes, sir. I think we can take up the questions. I think.
Yeah,
A few people have raised their hand.
Yeah, please. Yeah, Ravi, can you please read Ravi one by one? Then we can start
Yes, sir.
answering them.
General Optics Asia Limited.
Okay.
Yes.
Yeah, you can ask the question, sir. Now.
Sir, I have one doubt.
Yes, sir.
You have explained about fixtures designing, fixtures concept and fixture designing.
Yes, sir.
And that CLRO.
Yes, sir.
And that C is for clamping.
Yes, sir.
L is for location.
Yes, sir.
What is the R? O is for orientation. R, what is the meaning of R?
Bala, you would like to say this, or they let them join our courses? Mr. Bala? Mr. Bala? No, or is, you want us to answer, Bala? Okay, fine. Just make it fun. Or is called resting.
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 Location and resting.
Generally, yeah, resting. Let me just write it. This is basically CLRO. Or is for resting. Sorry, I'm just trying to resting, because when the resting is being used in various places, when your component is little bigger, you need to use a resting pin. Sometimes it's been loaded with a spring loaded or common, or if you want to do that, that's called resting. Thanks. Yeah, it's fine. Yeah, it's fine.
Next one is Mr. Mahendran. Mahendran R.
Yes.
Hi, sir.
Yes, sir. Yes, sir. You can ask now. Yeah, tell me, Mr. Mahendran.
Yeah, they can chat, Ravi. They can do two things, Ravi. They can either chat or they can do the maybe.
But they can speak out, I think.
Yeah.
Mahendran, can you speak now? You can speak.
I have no doubt, sir.
Okay. You have raised the hand. That's the reason.
Yes, yeah, please. So both the way we can do. Either you can raise a hand and you can ask, or you can type it in the chat box. We are ready to answer the questions.
Now, any more questions you can ask participants?
Yeah, Ravi, it's still 27 response only. Maybe we need to really wait for some more time. Yeah, please, all of you, please keep filling. We can wait, and maybe we have to just wait for some more time. I'm okay. I'm done. Oh, wow. Okay, you can share all these marks. Will be good. Somebody want? Oh, very nice. 6 out of 10. Fantastic. Good.
Thank you, sir.
Congratulations. You'll be awarded with a certificate from GKDTR. Fantastic. I'm very happy. Wow. Mr. Badri, 7 out of 10. Wow. Wow, Mr. Manohar, 9 out of 10. Oh, Mr. Karthik, 6 out of 10. Fantastic. Very happy. Good. Maybe, Mr. Bala, we can take it off. Who is a high scorer? I don't know whether it is possible or not. Earlier, I used to send some book. Maybe I will try to do something. I can do that. I will take some address, then call you. And generally, we have a practice of gifting a book. We'll try to send you this. I'm very happy. Somebody even scored 9 out of 10.
9.
Fantastic. Keep pouring. Yeah, please. We'll wait for all of you. And any questions, please do ask us. And we are GKDT here. And
parallelly, whoever has filled up, if they have any doubts, they can ask.
Yeah, it's a good time, and I know that it's on. I'm between your dinner or maybe tea and the webinar. And once everybody done, Mr. Bala has given a green signal, we can conclude. And it's open to you session. Any questions you can ask. Wow, Mrs. Sivamani Kamalesan, 9 out of 10. Wow, fantastic, Mrs. Sivamani. Congratulations. One or two or a few questions we made it very tough, and 3, I don't know. Ravi, am I right, Ravi? When we are discussing, we don't know. That
out
was
of 10, 7 will be very, very straightforward. So 3
will be very tough. I'm very happy. And 5 or moderate, we kept it with easy, moderate, and we are very happy. Good. Oh, wow, wow. And we are also trying to see the report. Wow, more response started coming. Around 40 started coming. And your choice. Only very few started showing their score. If more score is answer is coming, I'm very happy. Otherwise, it's not a problem. It's not a public. We are happy to answer all your queries or any doubt. Please do contact us if you want to learn more, because whatever we have showed is just tip of iceberg. And if you want to learn more about picture design or any of these courses, please do contact GKDITR or us, and we are going to share you at the end our contact details. And we are here to make you to grow in your career or increase your productivity in your company. So this is what we are always looking forward, and we want you to keep jumping between departments and grow in your career. And always people call it's called mid-career crisis. I don't know how many of you read the book, and there's a fantastic book. It's called Mid-Career Crisis. I really liked it. I read it. Vinith Nair, if I'm not wrong, the author name is Vinith Nair. I don't know if somebody is in mid 30s or 40s. Please read this book, Mid-Career Crisis. Fantastic book. And some of the takeaway from this book is people, whenever they grow in the age, they change their attitude. Because somebody is successful, after some time, they will start behaving like their boss. But no, of course, you can behave that, but it's very important. You should have your own uniqueness and keep changing the departments. All this is being mentioned. And maybe let me just see. Wow. More questions started coming. And please, in between, if you have a doubt, you can keep answering. We'll keep answering. Any other questions? Mr. Bala, you'd like to take lead, Bala? Out of almost 40 people have responded. You'd like to have some more thought process? Or if you want to run some few videos, I'm okay. I will just close it off. Or
no, Ajit, we have I think only 4 minutes.
Okay, fantastic.
Okay.
Yeah, 4 minutes. Absolutely. Sorry, we took additional maybe 20 minutes. It's fine. Yeah. Wait for 4 minutes, then we can close down. And thanks a lot, Mr. Dominic. 6 out of 10 is a fantastic answer. And just keep rolling up. Take your own time. There is no urgency. We have 4 minutes time. And again, for the benefit of people, we are just trying to show you all this. We jointly work with GKDITR, and we can make you move around the skill sets. And that's what GKDITR, and we assure you. And departments, if you're trying to change over, and the same department you want to master it, we are here to support you. We can close at another 4 minutes time, and people are keep rolling out, and I will also see the answer. Mr. Manokar, thanks a lot. Oh, fantastic. See you on next webinar. Thanks a lot. Any questions, please do ask us. We are waiting. People always say we got only one question. If at the end of webinar, if you have any more questions, we are very happy. And if there is no, I'm happy at least one question. If no question, either people understood fully or they do not understand anything. I hope so, everybody. I take it a positive way. You understood everything. And a pessimistic way, people do not ask questions, do not understand. No problem. Any one more question of anybody? We are ready to answer. Wow, Praveen, 8 out of 10. Fantastic. Wow. Ravi, yeah, maybe keep rolling. Yeah, we'll still wait for a few more minutes. Bala, you can take, Bala, whenever you want to conclude, you can conclude, Bala. We are through. People are still keep popping in. I hope so that link is still open. They can do that. And maybe any more questions we can keep asking, then we are ready to answer. Any one question? One more question? Okay, fine.
Okay. Sansagar.
Thank you, sir.
Yeah, thank you.
So, million sincere thanks to you for the sea of wisdom and knowledge you showered with us during the amazing lecture. You are too excellent. We would like to thank our managing trustee, Madam Dr. Dalida Devi Sanjay Jayavardhana Velu, and our director, Dr. Balamurugan M, for organizing this webinar. Great. Thank you, everybody. We appreciate your being here. So the YouTube, you can see this
seminar and webinar is available in the YouTube. We love to hear from you. Thank you.
Thank you. Thank you, everyone. We are just checking out. And if there is no question, we are, thanks a lot. Bye.